Hello guys, welcome back to my channel, Mason African Motives. Still working on the daily platform classes on mathematics N2. So in this case, we shall be actually focusing on exponents, still a continuation from the exponents and logarithms, but this time specifically we want to focus on logarithms. Remember, we worked on exponents, but we didn't focus on logarithms. So this is the class that we shall be having, which we shall be focusing now on logarithms. So definitely guys, if you're part of the family, you can consider subscribing so that you become part of us and work from Mason African Motives. So let us quickly cross-check what we have here on logarithms. Okay, the idea that actually happens when you are working with the logarithms actually guys are the laws. You have to know what are referred to as the laws of logarithms. All right, so before that, I just want to refer something here so that we can understand what's actually happening and the way how you present logarithms, just a basic part of logarithms. Okay, if I am given log a be like this means log a, so it's log a in base b, log a in base b, so this is the base. All right, so just like this, log a number like this, so it's log 2 base 3. So these are in line, the base is under this g, this base should be under this g like that. Okay, so when I am given log 5 like this, okay, what does this mean? Because I'm not given a base. Okay, on a condition like this, it means you are going to use the normal base, which is a base 10. That is whenever you are not given a base, you are going to use a base 10. So this is going to be log 5 in base 10 like this. That is how you represent these logarithms. So it's log of a number and a base. All right, so once you know how to present or represent logarithms, then now we can be able to focus on the laws of logarithms. Then how to use the laws of logarithms to simplify certain expressions under logarithms. All right, so I'm just going to list the laws so that we can be able to apply these laws. Okay, so I'm just going to use m and n so that you'll be able to understand me. Okay, let's say you are adding logarithms. You are given in bases which are the same. Like this case, I've got log m base a plus log n base a. These two, they are adding, and we can see that the bases are the same. This is base a and this is base a. So on a condition like this, you just multiply the given numbers. So in this case, we've got the letters m and n. You multiply them together under the same base. So like I said, I'm going to explain this later on. At least let us take this down so that at least when I'm now explaining, we will be understanding what I'm explaining. So this time we can be subtracting logarithms. We divide the numbers now. So we are going to divide them under a base of a, the same base which is a. All right, so that's another law. Then we can be given a condition where there is a number which is multiplying a log like this, p log m base a. This number, taking this p like a number, it's multiplying a log, you raise it to be the exponent of the log. So it's log m to the exponent of p in base a. All right, I hope you just take them down so that at least when we are to use this, we can at least understand the basic part that I'm talking about here. All right, so we can refer to this as the laws of logarithms. Okay, that is fine. Then we have some basic, I'm going to bring them down again. Then we've got some basic concepts which we need to know also about logarithms. Which are these concepts that we are talking about that can be best to know before someone approaches exam? Okay, these are the concepts that you're supposed to know, that whenever you are working with a logarithm of a 1 in any base. So this is actually logarithm of 1 in any base. So a is representing any base. It can be base 2, it can be base 4, it can be base 7, it can be base 10. Any base of your choice, you are going to obtain a 0. Okay, so that's the first concept that you're supposed to know, that logarithm of 1 in any base is equal to 0. That's log of 1 in any base is equal to 0. All right, so that's what you are going to have there. All right, the other concept that you're supposed to know is a logarithm of a number in the base of that same number that you're talking about is going to give us a 0. So what am I referring to? Maybe we are given log 2 base 2, it's going to give us a 1. Maybe you are given log 10 like this. So for log 10, they don't write a base because they know that you know that when the base is not given, it means you're in base 10. So the moment I see log 10 base 10, I'm going to say a 1 because the number and the base are the same. The number and the base are the same. So these are some of the concepts, guys, which are very, very important when you are working with logarithms. Okay, then all the other concepts, you're going to work from them, from the idea also of exponents. Remember, this is exponents and logarithm. That's logarithms. That's why you need to know the relationship between these. Okay, so using this concept, we also have this relationship between the exponential form and the log form. So we have got the relationship here between exponential form, that's an exponential form there, exponential form and log form. All right, what's the relationship, guys? What do we have there? So take note, guys, just write it properly there. So we need to know how these two are related. We are talking about exponents in our previous class. Now we are talking about logarithms. How are these related? All right, this is the relationship that you're supposed to know. In exponential form, you will be given maybe a to the exponent of b, which is equal to c. This is what we are referring to, exponential form. If you still remember from our exponential equations previously, we had a number to the exponent of something which was equated to a certain number like that. All right. So how am I going to relate this to log form? Okay, this is going to give me this in log form. So in log form, this is going to be equivalent, or is going to be the same as logarithm of, take note, the number which is your answer here, which is c. So we've got c here as our answer, and the base, which is b. So it's going to be log of c in the base that we're given here, which is a, which is going to give us the answer here, which is the exponent b. So take note, guys, it's log of this number in the base. This is your base, and your answer is the exponent. So you can convert also back from log form to exponent form. So which means if you are given a single log of log c base a is equal to b, you can write it as a to the exponent of b, which gives you a c in what? In exponential form. So these are the two forms you can write. What I'm simply saying, guys, is that when I know that 2 to the exponent of 3 is equal to 8 like this, or 8 is equal to 2 to the exponent of 3, it's one and the same thing. This is an exponential way of indicating numbers. That is not a log form. So I'm saying we can write this way in a log form now, where in log form it is going to be log of the number, which is, this is the number that you're talking about, the number without the base, or this is what you're saying. So this is log of 8. In base, the base, it remains the same. This is the base here because it's raising an exponent. This is the base here raising an exponent. So it's in base of what? 2. Is going to give us the exponent now, which is the exponent is what? Is 3. So this is now in log form. So that's how you convert from index form to log form, or from exponential form to logarithmic form. All right, so we are going to see this part. Actually, what we just need is to know the concept, because we are going to apply it later on when now we'll be solving logarithmic equations. So for the meantime, what we need is this relationship between exponential form and the log form. All right, so now using this relationship, there are ways that I can use to simplify. This is the first part that we want to talk about on simplifying logarithms. Okay, so how do I simplify logarithms? This is the first method. I'm going to explain two methods. Okay, simplify logs. How can I simplify a condition of maybe I'm given a log and I want to simplify that logarithm? Like let's take for an example that we have got log of 8, which is in base 2. Yes, we know that our calculators can give us an answer there. But the question on logarithms is always, do not use a calculator. And when you use a calculator, definitely they will see that you have used a calculator, because using a calculator, you're just going to obtain an answer here. But without using a calculator, there are some steps and stages that you are supposed to show. So which are of these stages? Okay, I've got the first method, which I'm going to explain from the relationship that we had from the exponential and index form. What I'm going to do is to introduce, since I know that this logarithm of 8 in base 2, it is going to give me a certain answer. All right, like I don't know if this light is going to allow us to put a calculator. Okay, it's fine for today. Okay, what I'm saying is that there is log here. Take note, we have got log 8 like this, log 8 in base 2. So this part which is indicating here, this part that is indicating, that is the base, and this is the number where you put 8. Okay, so this part that is indicating now, that's base 2. Okay, then you move aside, this now indicating this part where there is 8. It's like this. Okay, then equal to, so that is the answer, which is what? Which is 3. All right, but are you saying that we just obtained a direct answer, which is 3, of which the concept, it does not allow us to use a calculator? So calculators can be there to help us or to assist us to know that whatever I'm going to simplify here, I'm going to obtain an answer, which is what? Which is 3. So this can be used as a guideline when you're simplifying. Okay, so what am I going to do? This is the concept, guys. All right, I'm going to write it like this. I'm going to let this logarithm, because I know it is going to give me a certain answer here. So since I don't know the answer that I'm going to obtain, so I'm going to let this logarithm of 8 in base 2 to be equal to a certain answer, which is I do not know, which is x. So let it be equal to x. So how am I going to find this value of x? Because I'm supposed to calculate the value of x, because the value of x is the answer that I'm supposed to get. That is where I am going to introduce the relationship between the logarithms now and the exponents, because I know that I can convert from this log form back to exponential form, where we say it is the base to the exponent of the answer, which is going to give us c like this. All right, so this is what we have here. This is the base that we are having, and this is the answer. So we are saying this number 8 that we have here is equal to 2 to the exponent of x. That is how you can simply take it. Okay, you just take this number 8, you write it first, is equal to 2 to the exponent of x, or 2 to the power of x. Once you can write it like this, which means you can solve for x. Why? Because remember guys, we worked with exponential equations where we talked about like bases. If you still remember, we talked about like bases, where we said if numbers can be expressed in the bases which are the same, it means the exponents are the same. So which number can I use so that these two can be the same? As you can see, already 2 is in its simplest form. There's nothing that we can do here, so we're just going to rewrite as it is. But I can write this 8 in terms of base 2. So 8 is the same as 2 to the exponent of 3 from your calculator. So this is 2 to the exponent of 3. So as you can see, this base here and this base here are the same. So therefore, the exponents are the same. So therefore, you've got x, which is equal to 3. But this x that we are talking about, it is the x that we introduced. Remember, we introduced a certain letter to represent our answer. So this x is representing the answer to log 8 base 2. So it means, therefore, the logarithm of 8 in base 2 is equal to 3. Okay, which is the one that we did by calculation. So as you can see, we're obtaining the same answer there. So like I'm saying, using a calculator is not required, but you can use a calculator as a proof now to prove that your answer is correct or not. If it is not correct, therefore you have to redo the working again until you obtain the exact answer that you are obtaining from your calculator. All right. Like I said, this is the first method that we have. All right, this is the other method that you can do to simplify logarithms. So you can just write this as method 1. So this is the method 1 here. So you're going to choose which one is the best from these two methods that we are going to. So this is method 1. Okay, so let's see what we have on the second method. So still on simplifying logarithms, but using another method now. Which method are we talking about here? We are going to talk about the change of base. The change of base. All right. What do we refer to when we are talking about the change of base? Okay. The change of base is a condition where I am given a certain logarithm. Take note, guys, I am given a certain log which I can write in another base of my choice. Like let's talk about this. Logarithm of a number. Let's just choose a number of your choice. Most of us, we are used to x and y, or maybe a and b. Okay, but I can choose this logarithm of x in base a. All right, this is what I'm having, guys. It's a single log that I'm giving. So when I'm talking about the change of base now, I can write this in a certain base of my choice. This same log that I'm having here, I can write it in a certain base of my choice. But when I'm writing in that, this is the law, we are going to ignore a first, so it's going to be log x in a certain base, so you can choose any base of your choice, so you can say base c, okay, over, we are now at a, so it's going to be log of this number a. Take note guys, log of this number a, so it's now log a in the same base which is c, since we changed to a certain base. Okay, so this c is representing any base of your choice, any base of your choice. So what do I mean here? I mean that I can write a number like log 20 in base 5 like this. I can write it in any base of my choice. I can write this as log 20 in base 10 over this. I started with 20, then 5 over log 5 in base 10. That is the change of base. So it's log 20 in base 10, log 5 in base 10. So this 10 is any base you choose. Someone can write this as log 20 base 3 over log 5 base 3, as long these two bases are the same. That is what you can do. Okay, so simple, I think. Now, using now this change of base, which is this method, how am I going to simplify or evaluate logarithms now? All right, this is the idea. We had a question which was log 8 base 2. If you still remember, this was our question, guys. We wanted to simplify this. So using the change of base, what you are going to do now is to rewrite this in another format, which is that method here. This is what you're going to do. This is what we have, guys. Log x base a is now log x base a certain number of your choice, so you can choose a number of your choice. But I want you to take this, guys, as an advantage, so that you can know what I'm trying to say here. Since I'm supposed to write this as a certain base, like of my choice, I'm choosing the base of my choice. When I am simplifying a certain logarithm, like what I'm having here, it is best to choose the base which is already the base that we are given here, which is 2. Okay, what do I mean? I'm saying it is best to write this log 8 like this. So you're going to write log 8. Which base are we talking about, or which base are we now? We are in base 2 already. Take note. So it is best to write it. You repeat this. So guys, do not confuse. Remember, I said we want to write this. Okay, let me explain this way so that someone can understand me here. Log 8 base 3. Let's not talk about 2, because if I use 2, you won't see what I'm trying to say. Okay, we said if you are given log 8 base 3, you can write this in terms of another base. Okay, like log 8, you start with 8, you choose any base of your choice for this 8. So I'm just going to choose like 5. Okay, over the same thing, which is log 3 in base of the base that I choose here is the same base that I'm going to choose here. Take note. All right, so now I am saying you can take this as an advantage, since this base, we are the ones who are choosing this base. Okay, so let's say, because remember this 5, we choose this 5. Okay, so let's say this time I don't want to use this base 5, I want to use another base. I want to use the same base, which is 3, because I'm the one who's going to choose this base and I want to use 3. So I'm going to write this as log 8, which is log of this number. Then the base that I have chosen to use is base 3. This is the base that I have chosen to use. So it's like I am rewriting this, but it's not the same. Okay, over log, I'm now at 3, so it's now log 3 in the base that I have chosen, which is what? Which is base 3, like this. Still, it's one and the same thing. I can rewrite the same thing over like this so that I can simplify. So this is the part that I was trying to explain here, that if I am given log 8 base 2. This one that I was given here, log 8 base 2. Okay, we are going to start with log 8. So this is log 8. And I choose to use this base, which is 2. Okay, so you're going to see the advantage of this over log. We are now at the base now, which is 2. So it's now log 2. In the base that I have chosen to use base 2. Okay, so this can be written like this. So here I didn't like change the base. I just maintained the base which was there. So it's one and the same thing. That is the base that I have chosen to use. So I can choose to maintain the same base. Why do you choose to maintain the same base? Okay, this is the importance. Since these two numbers are in the same base, it means this is same thing as just giving us a 1. It's just like we are having a 1 there. We are just like we are having a normal 1. Okay, this is what we are having. So what am I trying to say? Let me take you back here. Remember what we said here. Logarithm of a in base a gives us a 1. So this is the same thing as just a 1. So you are going to see that this is just going to remain back to log 8 base 2. But if it was a condition that the 8 base 2, this one was in the denominator here, it wasn't going to remain like that. It was going to remain as 1 over log 8 base 2. But 8 base 2 is on top, so any number like 2 over 1, it gives you 2. 3 over 1, it gives you 3. There is no effect. So that is why this is going to change back to log 8 base 2. That is why you see when they are working with a bigger number, when this is a bigger number and this is a smaller number, they just rewrite as it was. It's because of this concept. Okay, so now what was the original concept actually? The original concept was that if this can be written in the same base, I'm going to obtain a 1. Then this one, I can simplify it also to be in the same number of base 2. Okay, so this is the concept. So I hope you understand that here there's no effect, but this log 8 base 2 that we're talking about, we can write it in the same number as 2. So it's going to be log 2 to the exponent of 3. 8 is 2 to the exponent of 3. Okay, then from this part that we are having, sorry, I want to put the base there, which is in base 2 actually, like this. I forgot that we are no longer working with this part because we said this gave us a 1 and it's this part, so there's no need of us like dividing. Maybe we can just do it. Okay, let's just do it, divide by 1. But remember guys, I said over 1 does not change. Okay, but this is what we're supposed to do, to divide over 1 like this. Okay, then what am I going to do? I'm going to drop this exponent here, 3. Which law am I using now? We are now back to the laws of exponents here. Remember from our laws of exponents, when I am having an exponent here, I can use this as p log m base a. If you're multiplying, like p log m, this is multiplying, but it can be used as an exponent. So it's the same thing. Here is the exponent. So you're going to drop down this exponent like this. So it's going to give you 3 log 2 in base 2 over 1. Okay, now we are now back to that same log 2 base 2. We are back to the same log 2 base 2, which you said is going to give us what? A 1. So log 2 base 2 is a 1. So 3 times 1, that is 3 over 1, and 3 over 1 gives us what? Gives us 3. So as you can see, we are obtaining the same answer like the one that we did using another method. So these are the two methods that you can use to simplify logarithms. Okay, so what do I mean, guys? I mean that, let's say we are simplifying a number like log 5 base 25. We have got two options, first one and this one. Okay, so this one, we said we can change this to a certain base. So I'm going to choose log So now the question is, which base am I going to choose in this case? I'm going to choose the base which is the simplest between these two numbers, which is 5 and 25, which is the simplest number here. The simplest number is 5. So I'm going to choose base 5. So I'm going to write this as log. Okay, we are starting with 5. So I'm going to start with the log 5 in base 5. The base should be the simplest one, the smaller number, or the simplest, in its simplest form. Take a note of 25. 25, there is 5 times, it's 5 times 5. So this number is not in its simplest form. I cannot choose to be my base, okay? Over, we are now at the base, which is 25. So it's going to be log 25 like this. In which base? In the same base that we have chosen. We have chosen 5 to be our base. So it's going to be like this. All right. Now let's move on. We are going to rewrite this. Remember, we said from our basic logarithm of a number, when it is the same as that number, logarithm of 5 in base 5, this is going to give us a 1. But this time it's over now because it's on top this one. So it's 1 over. Okay, how can I write this 25 in terms of 5 so that I can use the same concept here? So 25 in number or in base of 5, it's 5 to the exponent of 2. So this is going to be log 5 to the exponent of 2 in the base of the number, which is 5. All right. That means now I have got the power to drop the exponent like 1 over. I use the law. Remember, we talked about this law previously here, that when you are given the exponent, you are going to drop this exponent here to multiply the log, just like here. So you are going to drop this exponent, which is 2. So it's going to be 2 log 5 base 5. Okay, of which log 5 base 5 gives you a 1. It's going to obtain 1 over 2 times 1, which is 2. Okay, so this is going to be your answer. So that's how you can actually simplify this. Okay, maybe because of the numbers that I'm using, maybe they can be confusing numbers. I want to take a condition like this where we are not having the numbers which are the same, so that you know how to choose the base, like this one. It's log 64 base 32. Remember the question on logarithms, guys, you do not use a calculator. Okay, so the question is going to be simplify like this. You want to simplify this. Okay, so remember we said we've got two options, but I want to focus on the change of base. The other method, work with it also. Okay, so on this part you see that we are going to choose a certain base here. So it's going to be log 64. Okay, which base can we choose between 64 and 32? Which is a common base between these two numbers? You will see that 64 and 32, guys, they've got something to do with 2. These numbers, they've got something to do with 2. So you're going to choose 2 there. So it's log 64 base 2. Okay, over 32, which is log 32 in base 2. So this is the base that you have chosen, which is 2. Now you can write this, because now this time you can't simplify, because this number and the base are not the same. This number and the base are not the same. So you're going to choose to write this 64 in terms of what? In terms of 2, because once there's a base, because remember what you need is that if the number and the base can be the same, it gives you a 1. Already the base is there, is 2. So you must write this number in terms of what? In terms of 2. Okay, so in terms of 2, we are going to find out that 64 is the same as 2 to the exponent of 6. This is the one that is going to give us 64. So we've got 2 to the exponent of 6. In base what? In base 2. Remember, we've got a base of 2. Over, we've got 32. You find out 2 to the exponent of 5 is the one that is going to give us 32. So this is going to be log 2 to the exponent of 5 in base 2, like that. All right. Now at this stage, that's where I now have that power now to drop the exponent. Now remember, we said whenever there's an exponent, you're going to multiply the exponent back to the log. So you're going to multiply 6 log 2 base 2 over, you multiply 5 here, so it's going to be 5 log 2 base 2, like that. So once this log of 2 and the base are the same, remember we said logarithm of a number in base of this number is 1. So it means here we've got log 2 base 2, which is going to give us a 1, log 2 base 2, which is going to give us a 1. That is the idea there. Or you can actually cancel these because they are the same. Instead of using log what, they are the same. So these can actually cancel and you remain with 6 over 5. So this is going to be your answer there, 6 over 5. So as you can see, guys, these steps and stages, they are not shown on your calculator. Your calculator cannot show these stages. So definitely when they ask you not to use a calculator and you use a calculator, they'll see that you've used a calculator. Okay, so that is the first class that you're having, what we had, guys. So shall meet again as a continuation from this part, actually working on more questions, like seeing how they ask these questions and so forth. So this is actually how we are going to have a layout of the questions like this. Evaluate the following without using a calculator. Okay, so that's what we had there. That's what we had there. All right, so like I said, we shall meet again working with questions from this exercise so that at least we can understand from the basics that we had from this part. But that's actually how we have these logarithms as the first part. So you try by all means to work with questions. So as you are seeing that we are asked not to use a calculator, so you are supposed to choose between the two workings that, or the two methods that I talked about. But that is the concept, guys. So we just meet again and see the areas that we can actually focus on so that we can have a clear understanding on these logarithms.